Hey there, Algebra 1 students. This is Mrs. Anspaugh, and I will be recording the Algebra 1C second trimester exam. There are 54 multiple choice questions, and the remaining questions are short answer. However, for each question, I would like you to at least jot down your thoughts and ideas, show your work, show me your thinking, so that you can earn a point for every question in addition to the correct answer. So that's what I will be looking for. I will read each question. In addition to that, I will also give you some helpful tips, tricks, hints along the way so that you can be more successful on each question. So let's begin. Number one, which graph is the most appropriate to describe a quantity decreasing at a steady rate? So you're really focusing on the words decreasing at a steady rate. Number two, write a function rule for the table. Again, you're trying to match this table with its equation, so you need to first look at how the x values are changing in addition to how the y values are changing, or the output here. And so we're looking at the change in y's over the changes in x's, which will give us our slope or our rate of change. In addition to that, you might have to look at where your table is actually starting at 0 and where the number across from it is the y-intercept. Number three, you are asked to graph the function y equals negative x plus 3. So you will want to determine your m and your b before you begin graphing. Number four, a zucchini plant in Darnell's garden was 10 centimeters tall when it was first planted. Since then, it has grown approximately 0.7 centimeters per day. In letter A, write a rule to describe the function. In letter B, after how many days will the zucchini plant be 0.17 or 1700 meters tall? So you can see right away that they give you your starting amount, and they also give you your growth rate or your rate of change. Number five, the rate of change is constant in each table. Find the rate of change. Explain what the rate of change means for the situation. Again, you're looking for the slope occurring between the time in hours and the distance in miles. So you want to find the change in your time values over the change in your distance, and you're looking at the change in y's over the changes in x's, which will give you your rise over run. Number six, the rate of change is constant in the graph. Find the rate of change, explain what the rate of change means in the situation. So again, you're looking from friendly point to friendly point, what is happening each interval. You can count your rise over run from your little steps here, or you can also do a giant rise and a giant run from point to point. Number seven, find the rate of change for the situation. You run 4 miles in 1 hour and 12 miles in 3 hours. Number eight, find the slope of the line. Again, you might have to go through and put your points on the line so you can see nice friendly points before you determine the rise over run. Number nine, the same directions apply. Notice the directions of the graphs also will play a key role in the slope. Number 10, a student finds the slope of the line between points 11, 8 and 1, 1. She writes in the numerator 8 minus 1 and in the denominator 1 minus 11. What mistake did she make? Is it A, she mixed up the values x and y? Is it B, she should have added the values, not subtracted them? C, she did not keep the order of the points the same in the numerator and in the denominator? Or D, she used y values where she should have used x values? Number 11, state whether the slope is 0 or undefined. It's a little difficult to see in the video, but this is actually a horizontal line. It's easier to see on your paper. So this is asking what is the slope of a horizontal line, and number 12 is asking what is the slope of a vertical line at x equals 2 here. Number 13, use the graph to answer which plant was the tallest at the beginning, and part B, which plant had the greatest rate of change over 6 weeks. So which graph is showing the steepest line to determine the greatest rate of change. Numbers 14 and 15 are asking you to find the slope and y-intercept of the line. The first one is written in slope-intercept form, y equals 3/5 x plus 9. However, the second one needs to be written in slope-intercept form to determine the slope and the y-intercept. Number 16, write an equation of a line with the given slope and y-intercept. M equals 1/6, B equals 2/3. Number 17, write the slope-intercept form of the equation of the line. Again, you will have to determine the slope and the y-intercept. And the directions are the same for 18. Again, notice the way the line is moving from left to right here and where the line is moving from left to right here. Number 19, use the slope and y-intercept to graph the equation y equals negative 3/5 x minus 3. Yes, there is a negative there. Number 20 and 21 ask you to find the x and y-intercept of the line. Notice it's in standard form, so we use standard form to find the x and y-intercept. We made a t-chart in our notes, so that should be helpful for you to look at finding the x and y-intercept. Same is true for number 21. Again, it's in standard form. Your calculator may also be helpful at this point because our calculators do graph in standard form. 22, graph the equation y equals negative 3. Pay close attention that there is no x value in this equation. Number 23, graph the equation x equals negative 3. Again, pay close attention, there's no y value in this equation. Number 24, a line passes through the point 1, negative 5 and negative 3, 7. In letter A, write an equation of the line in point slope form. So you might reference your notes or foldables for that. Rewrite the equation in slope intercept form. So once you have it in point slope form, you will then have to distribute and solve the equation for y. Number 25, are the graphs of the lines in the pair parallel? Explain. So you're specifically looking at these two equations to determine if the lines are indeed parallel. In order to do that, you will have to write the second equation in slope-intercept form so you can compare the slopes and the y-intercepts. 26, the map shows Main Street and the construction site for the new school. Find the equation of a street that passes through the building site and is parallel to Main Street. So you're looking for one of these equations that is the same as Main Street. 27, write an equation for the line that is parallel to the given line and that passes through the given point. Notice the equation is y equals negative 5x plus 3, so it's already in slope-intercept form. So you will need to know about parallel lines and their slopes. In addition, you will have to use the point negative 6, 3. You are more than welcome to use point slope form or slope-intercept form to write your equation. Number 28, tell whether the lines for each pair of equations are parallel, perpendicular, or neither. Once again, neither of these equations are in slope-intercept form, but to be able to determine this, you need to write them in slope-intercept form. 29, only one of your equations is in slope-intercept form, so you will need to write the second one in order to determine if they're parallel, perpendicular, or neither. Number 30, write the equation of the line that is perpendicular to the given line and that passes through the given point. Notice it is in standard form to start with, so you will need to transform that to slope-intercept form in order to find its slope. Keep in mind it's not parallel, it is perpendicular, and it passes through 6, 10. So you can use point slope form or slope-intercept form to write your equation. Number 31, which graph shows the best trend line for the following data? Again, feel free to use your calculator to compare the graphs. Number 32, the table shows the amount of time a student spends practicing each week and her typing speed. So once again, it's asking you to use a graphing calculator to find the equation of the line of best fit. And part B, use your equation to predict the student's typing speed if she spends 8 hours practicing each week. Once you get your equation of the line of best fit, you will then have to go back into your graphing feature, type your equation in, and call up the table. Control T will help you determine and make this prediction. 33, Giselle pays $190 in advance on her account at the athletic club. Each time she uses the club, $10 is deducted from the account. Model the situation with a linear function and a graph. So you're looking for the equation that gives you your starting amount and your rate of change. Which graph represents the following systems of equations? So again, feel free to use your calculator, or you can use the slope and the y-intercepts to graph your points and determine the point of intersection. 35, use the graphing calculator to find the solution of the system. 36, tell whether the system has no solution, one solution, or infinitely many solutions. Notice both of these are already in slope-intercept form. And in 37, you will actually have to write one of these in slope-intercept form to make the decision. And 38, y equals 2x plus 4 and y equals negative 4x plus 3 are already in slope-intercept form. Numbers 39 and 40, you're going to be asked to use substitution to solve this linear system. Notice y is already solved, a variable solved by itself. And in number 40, solve the system using elimination. And notice your x's are lined up, your y's are lined up, your constants are lined up, so you should be able to eliminate. 41, solve the system using elimination. And again, you might have to multiply one of the equations by a number in order to eliminate. And in 48, you might have to multiply both equations by a number in order to eliminate. Number 43, this actually begins our post-test from our pre-test that we took at the beginning of the unit on linear systems. So number 43, which is not a method for solving a system of equations? Graphing, substitution, fundamental theorem of arithmetic, and linear combination. Number 44, if a system of equations has no solution, what does the graph look like? Intersecting lines, parallel lines, skew lines, same lines that coincide. Number 45, solve the system of equations using the graphing method. Use your calculator to check your solution. What does the graph look like? Again, I provided graph paper for you to do this and show your work. Number 46, solve the system of equations using the method of your choice. Number 47, what is the correct first step to solve this system of equations using elimination after you have actually eliminated a variable? Number 48, solve the system of equations using the method of your choice. Select the coordinate that is the solution to the system of equations. I will point out to you that your x's are lined up, your y's are lined up, and your constants, so elimination might be a very good choice here. When using substitution to solve the system of equations, what is the result of the first step? That's 49. Number 50, if linear combination elimination is used to solve the system of equations, what is the result of the first step? Number 51, translate the following sentence into an equation. The product of 9 and 4 less than n is 27. Simplify the expression x plus 6 plus x plus 3. Number 53, solve the equation 3x minus 1 divided by 5 equals negative 8. Number 54, find the slope of the line that passes through the points 4, 4 and negative 4, 6. That concludes the multiple choice section. We now will move into the short answer section. Solve the linear system using the method of using the graphing method. Write your answer as an ordered pair. I will point out to you both of these equations should be written in slope-intercept form before you begin graphing. Number 56, solve the linear system using substitution. Write your answer as an ordered pair. Again, I'll point out to you that one of your variables is already a single variable. Number 57, solve the linear system using linear combination or elimination. Write your answer as an ordered pair. Again, your x's are lined up, your y's are lined up, and your constants are lined up. 58, solve the linear system using any method of your choice. Write your answer as an ordered pair. I did provide graph paper in case you choose to graph this. And the same is true for 59. Solve the following system of equations using any method of your choice. Write your answer as an ordered pair. Again, I provided graph paper in case you choose to use the graphing method. And 60, write a system of equations and then solve them by the method of your choice. Reserved seat tickets for the football game cost $4 each and general admission tickets cost $3 each. After the game is over, the turnstile count shows 1,787 people attended the game. The total receipts were $5,792. Find the number of each kind of tickets sold. Again, I will remind you when you're writing your equations in standard form to keep your money together and keep your people together. Don't blend the two. So good luck. I know you will do awesome. We're shooting for that 80%. Go get them and peace out.